So today and we'll be focusing upon how to handle null values with SQL statements, and further we are going to look at few advanced constructs of SQL statements. So today we'll be focusing upon few constructs under nested subqueries. So to begin with, let us see what are null values and how to handle those null values with our select statement. Many times it happens that whenever we input data, we are not having certain values known at the time of inserting the data. Or sometimes it may happen that for a particular attribute in the table, the value for that attribute does not exist. So in these situations, what we input for that particular attribute for a specific tuple is the null value. So it is possible for tuples to have the null value, and this null value is denoted actually by the spatial value null, right? And it may happen that sometimes attributes are having their values null for specific tuples. As I stated, null signifies an unknown value or the value does not exist. So what are the possible reasons that we are having these null values? So let us assume that, say for example, we are having one table, right? Say we are having student table. Let us assume we are having the student table. And in this student table, we are having the columns like name of the student, then address we would like to store, but address is having several parts, right? So let us assume that we are having the attribute address 1, address 2 and so on, right? And if we are inputting the data for this student, one specific student with say name X, it may happen that for this student both the attributes are having certain values. So address 1 will contain some value and also address 2 contains some value, right? So both the attributes are having the values, so no issues. But if we are having another tuple for student say Y, it is possible that we are having only the attribute value for address 1, right? But we are not having any value for this address 2 attribute because the value does not exist for that particular attribute for this particular student Y. So in this situation, what we need to do is we need to input the value null as the attribute value for this address 2 attribute, because this address 2 value does not exist for this particular tuple. For other tuples, the value may be there. Okay. In some other situation, suppose we want to store in this table, we are having one more attribute, say total credits for the student. Okay. Now, in this situation, suppose it may happen that for a particular student, the total credits are not known whenever we are inputting the data, right? So later on we are going to input that value, but initially we are not knowing that value, right? So this attribute value is null, not known, unknown. So in that situation also we need to input that attribute value as null. So this is how there are several reasons why we are having null values in our tables. Now later on, if we want to find out the tuples for which some attribute is having null values. We'll repeat. Suppose we want to find out the tuples such that for some attribute the values are null. Right? Then we are having a predicate is null in SQL that can be used to check for the null values. So let us see the example. Suppose we want to find out all instructors for whom the salary value is null. So it has happened that the instructors, or initially while inputting the data for the instructors, for few of the instructors the salary value is not null, is not known, and that is why initially the salary value is inputted as null. So later on, whenever we are having available that data, we once again would like to update those values, right? So for that reason, we want to find out which are the instructors for whom the salary value is inputted as null, right? See, for example, if we want to find it out, we may write the statement like select name from instructor where salary is null. So this is a predicate that can be used to find out the tuples of the instructors for whom the salary value is unknown, is null, right? So the construct that we are using is this, is null, right? So let us try to implement this in Oracle. So how we are going to use this? Okay, so let's first of all find out, or let us list out the instructor tuples. So select start from instructor. This statement will show us the data that is stored in instructor table. So we are having 12 rows, 12 records, 12 instructors. Those are stored in instructor table, right? Presently, all the salary values are non-null. So we are having all the data for salary available. So to try this query, let us first some salary value to null, and then we'll try how our query works. So let us try to update instructor table to null. So if I give such kind of a statement then what will happen? All the salary values will be replaced by null. We do not want that. We do not want to replace all the salary values by null. Instead, we want to specifically replace one of the salary values as null. So we need to provide the where clause here. So update instructor set salary equal to null where suppose for this first tuple with the instructor Srinivasan and ID 10101, we would like to replace the salary value by null. So update instructor set salary equal to null where ID is equal to 10101. So let's try to modify this salary value first. So I'm executing this statement. So one row is being updated. So if we try to list out once again all the tuples, then look at this. For this 10101, the salary value is replaced by null value. right? Now, what we want to find out the tuples for which the salary value is null. So how we are going to write this statement? Select name. We want to find out the names of the instructor for whom the salary value is inputted as null. So select name from instructor where salary is null. So this is the predicate that we are using, is null. Salary is null. So select name from instructor where salary is null. So after executing this statement, what we are expecting is the instructor names for whom the salary is null. So presently in our table we are having only one instructor for whom the salary is null. So we should get this name Srinivasan as the output. So let us try this. So look at here, after executing this statement we are getting one instructor for whom the salary is null. Right? Now, similar to this is null, we are having another clause is not null. So suppose we want to find out the instructors for whom the salary is having some value. Salary is not null. So simply we may replace this predicate with is not null. So select name from instructor where salary is not null. So if we try to execute this, we are getting all remaining instructors other than Srinivasan for whom there is some salary value present in my table. Right? So we are having these 11 instructors for whom salary value is available. Salary is not null. Whereas if we write this statement like select name from instructor where salary is null, we are getting one record Srinivasan for whom the salary is null. Right? So this is how we should use this predicate is null or is not null to find out the tuples for which the specific attribute value is null or not null. Right? Are you getting me?
Yes,
Yes?
ma'am. Yes,
Fine.
ma'am.
So let's proceed now with some manipulations with null values. So if we are trying to provide the arithmetic expression that involves the null value, I'll repeat, if we try to provide the arithmetic expression that involves the null value, then the result of this arithmetic expression will be null. Say for example, if I am having some attribute value in my table that is null, and if I am adding some value of, or if I am subtracting, multiplying, whatever it may be. So if I am using some arithmetic expression wherein this null value is involved, then this arithmetic expression will return me the value null, because null is not known, it is unknown value. So 5 plus some unknown value is obviously null, so it is not known also. Right? So the result of any arithmetic expression that involves a null value is always null. Right? Now, let us go through the three valued logic that involves the null value. Say for example, if we are having any comparison with null value, any comparison with null value, then it returns unknown. What does this mean? If we are having the expression like 5 is less than null, or null is not equal to null, or null is equal to null. So all those comparisons will provide us the result as unknown value. Right? If we try to use the logical operators or and or not, then how these null values or unknown values will contribute into the result, that we are going to discuss now. So if I am using or operation, right, and if I am using, so obviously when I am using or, I may provide this or in my where clause. So where I am providing one predicate or some another predicate, right? So if this first predicate is giving me the unknown value, if this first predicate is giving me the unknown value, and the second predicate is evaluated as true, so ultimately I am having unknown or true, right? If I am having this combination unknown or true, then the result will always be true. Unknown or true is true. Similarly, unknown or false will be unknown. Unknown or unknown will be unknown only. Right? So this is how our logical operation OR works. So many times we need to provide the predicates and we need to use such kinds of logical operations, right? And when the entire predicate will be evaluated as true or false or unknown, depending on the individual results of the predicates. So if the first predicate is evaluated as unknown and second predicate is evaluated as true, and if we are using OR operation, then unknown or true will be evaluated as true. Unknown or false will be evaluated as unknown, and unknown or unknown will be evaluated as unknown. If we go for another logical operation, that is AND, then what will happen? True and unknown will be evaluated as unknown. False and unknown will be evaluated as false. And unknown will be evaluated as unknown. Right? If we go for NOT operation, then not unknown is evaluated as unknown itself. Right? Not unknown is evaluated as unknown. Okay? Now, if I am having such kind of a predicate, P is unknown, then this P is unknown will be evaluated as true if the predicate P is evaluated as unknown. So if this P is evaluated as unknown, then P is unknown will be evaluated as true. Right? So this is a final comment. Result of where clause. Result of where clause is treated as false if it evaluates to unknown. What does this mean? Suppose in where clause I am using this OR logic. Okay, in where clause I am using this OR logic and I am having two predicates. And let us assume that the first predicate is evaluated as unknown, right? And the second predicate is evaluated as false. So, unknown or false collectively will be evaluated as unknown. Right? So, this is the predicate that is evaluated under where clause. So in where clause, if my predicate is evaluated as unknown, then this entire where clause predicate is treated as false. So in where clause, if my predicate is evaluated as unknown, then that will be treated as false. Are you getting me? Yes.
Yes, ma'am. Yes, ma'am.
Right? So this we need to understand properly. So whenever we are having null values, then obviously if we are having null values in our tables, then sometimes we may come across the predicate that evaluates as unknown. And if we are having unknown as the evaluated predicate, then that contributes into evaluation of the predicate under where clause. Right, and based on that my entire select statement will be executed. So we should understand when it will be evaluated as false, when it will be evaluated as true, right, based on the null values, those result in the unknowns, right. So the next point that we would like to cover is how actually the null values affect the aggregate functions. So let us assume that we would like to find out the total of instructors' salaries. Total of instructors' salaries. So obviously we are going to use the statement like select sum of salary from instructor. So this statement select sum salary, sum is the aggregate function that we are using. So we are summing up all the salary values in our column salary, right, from instructor table. So if we are providing such a statement and if we are having few of the salary values, those are null, right, then the aggregate statement ignores the null salaries, right. I'll demonstrate you this concept practically, right. And this aggregate function result is null if there is no non-null salary. What does this mean? When this will provide me the null result? Only when all salary values are null. All salary values, if all salary values are null, then and then only it will provide me the null result. If one of the salary values is null, then that salary value is being ignored. So whichever are non-null salary values, the sum of those salaries will be provided. Right? So in general, all aggregate operations except the count star operation, all aggregate operations except count star ignore the tuples with null values, right, with respect to the aggregate attributes. Only count star will count even though there is a null value present in one of the attributes. Otherwise, all aggregate operations except count star ignore the tuples with null values on the aggregated attributes. So let us see this practically. So once again, let's go to Oracle. So let us list out the instructors, all instructors. So for one instructor, we are having salary value that is null. Okay. Now this instructor belongs to computer science department. So for simplicity, let us add one condition, select star from instructor where department name is equal to comp science. We'll be having 3 records. Those belong to computer science. Out of these 3, 2 instructors are having some salary values and 1 instructor is having null value as the salary. Now we are going to demonstrate how aggregate function works with null values, right? So let us try to write the statement like select some from instructor where department name is equal to science. Correct? So even though now one salary value is null, that should be ignored, and what we should get is sum of these 2 salaries, right? So select some salary from instructor where department name equal to computer science. So whatever we are getting is sum of these 2 values. So null value gets ignored if it is present. Right? Now let us try to use one more aggregate function. So see here, we are having 3 instructors from computer science department, and suppose we want to find out the average salary. So once again, if we are trying to find out the average salary, then this null gets ignored, right? And average of these 2 will be presented as the output, because one instructor is having null salary. Okay, so let's try to execute this. So it is 83500. So whether the average 83500, whether the average of 75,000 and 92,000 is 83500. Yes, check it out. Yes. Average of 75000 and 92000. What is the average? Yes.
920.
83500. Correct? So this null value is being ignored, right? And the average of these 2 salaries is presented. So all the aggregate functions except the count star function will ignore the null values with respect to the aggregated attribute. Now let us try to find out this count star. So what this count star will do? So select count star from instructor where department name equal to computer science. So we want to find out the number of instructors in computer science department. So if I am trying to find out the number of tuples, star means all attributes we are considering. So if we are trying to find out the number of tuples from instructor table for which department name is computer science, then I am getting count equal to 3. Right? So if I am using count star, then it will not ignore the null value. One of the tuples is having null value, right? But it is not at all ignoring that null value. It is giving me the count 3. Right? But if instead of this star, if I provide here salary, the specific attribute, select count salary from instructor where department name equal to computer science. So we are having 3 records belonging to computer science. right? That we have found out 3 instructors belonging to computer science, but out of these 3, only 2 are having some salary and one salary value is null. So if I specifically provide this count statement for this attribute salary, then what will happen? I am getting the count as 2. So it will count only the non-null salary records. Non-null salary records, and these are 2. Right? But if I am using count star, then it will ignore the null value. Got it? Is there any doubt so far? Yes? Is there any doubt?
No, ma'am.
No, ma'am.
These are actually very important constructs, and these are the most popular questions in your interviews. How to deal with null values, or how aggregate functions are dealing with null values, right? So these are actually the most popular questions in your interviews. So please understand the concept and please practice it so that you can understand what actually is happening, right? I hope you must have understood. So let's proceed now with the nested subqueries. We know the nested constructs. We know the nested constructs in programming languages. So we have seen, if we say in any programming language, if we are having nested for statements, nested for statements. What it means, nested for statements? We are having one outer for, and within that for, we are having another for statement. Or nested while statements, we are having one while loop, and inside that while loop, we are having one more while loop. So this is how few of the programming constructs can be nested, right? Similarly, it is possible. Similarly, it is possible to nest the SQL queries, right? So SQL actually is providing us the mechanism for nesting the subqueries, one query, and within that one query, we may have another subquery of the form select from where clause, right? So under these subqueries, we are having 3 important types of constructs under 3 categories, and these are set membership, set comparisons, and determining the cardinality. So we are going to look at all those different constructs under all these 3 categories of subqueries, right? So under set membership, we will provide nested subqueries. Under set comparisons, we will be providing set subqueries, and also determining the cardinality, we are providing the subqueries. So let us begin with set membership clauses. Okay, now let us see one example so that we can understand the concept. We want to find out all the courses those are taught in the semester fall 2009 and spring 2010 both. So we want to find out all the courses taught in both fall 2009 and spring 2010 semesters. So we have written this query earlier. If you remember, we have written this query earlier. And how we wrote this query? We want to find out the courses. Those are common. Those are taught in both fall 2009 and spring 2010. So we have written this query by making use of the set operation. And that set operation was intersect operation. So using this intersect operation, it is possible to get the result for this problem. Right? So what we are writing, select course ID from section where semester equal to fall and year equal to 2009. Intersect, select course ID from section where semester equal to spring and year equal to 2010. So this query is giving us all the course IDs. Those are taught in fall 2009. This query will provide us all course IDs. Those are taught in spring 2010, and we are finding out the intersection of these two sets. So the common course IDs we will be getting. Those are taught in both these semesters. Right? So this is one way of writing this particular query. Now we are going to make use of this set membership clause. Set membership clause, that is in. So in and not in are two set membership clauses. In and not in. So we are going to make use of now this in clause to write this query. So how we are going to write this query? Just look at it using this set membership clause in. So select distinct course ID from section where semester equal to fall and year equal to 2009. So up to this, the first part of the query up to this is same. So this select statement is giving me course IDs. Those are taught in fall 2009. Okay. Now in set membership, what we are going to do is we are going to provide now one more predicate in this where clause. So we are having and course ID in and course ID in, and then we are having this as the subquery. So this is my subquery. So in select clause, in select statement, select from where, in this where clause, I am including one more query, one more select statement. Right? So in outer select statement, I'll be having this inner select statement. And that is how we are making use of this subquery construct. Right? So please carefully look at this, how we are making use of this in clause. Select distinct course ID from section where semester equal to fall and year equal to 2009 and course ID in. Select course ID from section where semester equal to spring and year equal to 2010. So what this statement will do? This outer query will be executed first. So we'll be finding out the course IDs. Suppose 1, 2, 3 are the course IDs. Those are being taught in fall 2009. Okay. Now these are my course IDs. So what next we are trying to do is, if these are the course IDs, those were taught in fall 2009, then we are going to see for every course ID now. So this is nested subquery, right? So we are going to see now whether this CID, this course ID is present in the result of this subquery. So suppose the result of this subquery is providing me the courses, say 2 and 3. This inner subquery is giving me the result course ID 2 and 3. So what I am trying to do is, this outer query is providing me 3 courses 1, 2, 3. So I'll be looking at whether this course ID is present in the result of this subquery. So whether 1 is present in this result? No. Right? Whether this 1 is present in this result? No. So for this particular tuple, for this particular course ID, my where clause is evaluated as false, and that is why it will not be included in my final result. Then it will go for the second tuple. So this 2, course ID 2. So once again it will check whether this course ID 2 is present in this result. So this result means this inner query result. So whether this course ID 2 is present in this inner query result, yes, it is present, right? So this where clause will be evaluated as true. And as this is evaluated as true, this course ID 2 will be inserted in my result. Similarly, it will check for this third course 3, whether this course 3 is present in the result of this inner query. So course ID 3 is present in this inner subquery result. 3 is present. So once again, this where clause is evaluated as true. And if it is evaluated as true, then that course ID will be included in my final result. So ultimately, in this scenario, my final result will include 2 courses with course ID 2 and 3. So both these queries will provide me the same result. In the first case, we are using the set operation, that is intersect. In the second type of the query, we are using set membership clause in, right, which uses a subquery in where clause. Are you getting me? Yes? Is there any doubt? May I proceed?
Yes, ma'am.
Yes.
So let's execute now these 2 statements so that we can understand both are giving us the same result. So the first query we have already written earlier. So select course ID from section where semester equal to fall and year equal to 2009. So this is the first part of the query. Intersect spring. This is the query that is written by making use of this intersect operation, right? And we are getting one course that is being taught in both these semesters, fall 2009 and spring 2010. Now, the same result we can obtain by making use of this set membership clause. So how we are going to write this query now? See, select distinct course ID from section where semester equal to fall and year equal to 2009. Right? So this is similar to that of the earlier first part. And so in this where clause, we are adding one more predicate, and course ID in. We are writing now the subquery. Select course ID from section where semester equal to spring are equal to 2010. So this outer query will give me some result, some course IDs. So what I am going to do is that every course ID that I am getting as a result of outer query, for every course ID, I will be checking its membership in this particular set that is provided by this subquery. So select statement is included as the subquery in where clause. Okay. So let's try to execute this. We should get the same result. See, we are getting the same result. So both these queries are equivalent and providing us the same result. The construct that is being used is different. Got it? Is there any doubt? Yes. Is there any doubt?
No, ma'am.
No, ma'am.
Fine. So, I hope you must have understood this in clause. And similarly, we are having not in. So let us try to write this query. Once again, we have written this query earlier. Now we are making use of set membership clause to write the query. Find all the courses taught in fall 2009 semester, but not in spring 2010 semester, but not in. So earlier we have made use of this except, right, to write this query. So except is equivalent to set difference, and in Oracle, for this except, in Oracle, for this except, we are having the clause that is used is minus, right? In SQL, in general, the except clause is being used to find out the set difference. In Oracle, we are using this minus clause for the same task, right? Now, we have seen this query earlier. The same query can be written by making use of now the set membership clause not in. So see here simply how we are writing it. The way we write the query is similar to that of the earlier one. Only difference is we are making use of now this not in. So this outer query is providing me all the courses those are taught in fall 2009. This inner query is providing me all the courses those are taught in spring 2010, and simply what we are doing is whatever is the result of outer query, for every course ID in the result of outer query we are checking whether it is not present in the result of inner query, whether it is not present in the result of this inner query, right? So if this not in evaluates as true, then this entire where clause will be evaluated as true. Otherwise, it will be evaluated as false. So let us assume once again that the outer query is giving me the result course IDs, say 1, 2 and 3. Okay, and this inner query is giving me the result 2 and 3. So what will happen? We want to find out the courses those are taught in fall 2009 but not in spring 2010. So obviously the course with course ID 1 is taught in fall 2009 and it is not taught in spring 2010. So we are expecting this result 1, course ID 1. So how this query will be executed? So for every course ID, it will check whether this course ID is not there. We are using not n. Whether this one is not there. If it is not there, then this will be evaluated as true. Right? If this course ID is not in the result of this inner subquery, then that will be evaluated as true. And if it is evaluated as true, then that will be placed in my final result. So 1 is not there, so it is evaluated as true and that will be placed in my final result. Now, if we look at this course ID 2, this will check whether this course ID 2 is not in this result, not in. No, it is there. So not in will be evaluated as false. For this it is evaluated as true. For this too it is evaluated as false because it is present here and we are using not in. Okay. So if it is evaluated as false, then one of the predicates in where is evaluated as false. So entire thing, because we are using AND operation, this entire where clause will be evaluated as false and this too will not be included in my result. Similar is the case for 3. For this course ID 3, it will check whether this course ID 3 is present, is not in, whether this course ID 3 is not there in this result, but it is there. So this not in will be evaluated as false. So entire where clause will be evaluated as false, and that is how this 3 will not be included in our final result. So obviously our result will include only one course with course ID 1, that is taught in fall 2009 but not in spring 2010. Got it? Yes? Is there any doubt? So simply what we are using here is we are using not in. And if we try to execute this, these are the courses. Those are taught in fall 2009, but those are not taught in spring 2010. Correct? And if we use minus clause here, then also we'll be getting the same result. Is there any doubt? Yes?
No, ma'am.
Fine. So let's conclude today's session. We are supposed to have few more examples under this set membership clause. So we are going to look at those examples in the next session and then we'll proceed for the other categories under subqueries. Okay. So let's conclude the session. Thank you.